All right, so with that, I'm going to invite Stefano to turn on his camera, and I'm just introduce Stefano real quick. He has covered technical support, product management, business development, education, training, and a whole lot of other things. He's been consulting since 2017. He manages flexo.expert and flexo.training websites. Stefano is a member of ATIF, FTA Europe, TAGA Italy. He's a first certified implementation specialist. He's also part of the first committee, and he's part of the FQC committee. We keep Stefano very, very busy. So Stefano, welcome. Thank you for being here. I'm going to turn it over to you and take it away.
Great. So let me share my screen and we start from here. It should be okay. Just prompt me if there is anything that is not visible or not very good. So thank you, Joe. Thank you, FTA, for this opportunity. And hello, good morning, good afternoon, good evening, buonasera. I think the registered audience today covers a pretty wide range of time zones. So let's get started with this presentation. So how can color separations be sustainable? You know, the topic of sustainability today interests everybody, and it has important implications, especially within the packaging industry. And we know the environmental impact of packaging arouses extraordinary interest within the public opinion, and consequently in the industrial chain to which packaging printing belongs. Now, printing, in fact, is an essential complement to packaging, both in terms of aesthetics related to the identity and positioning of each product, and in terms of safety and consumer information, or to confer specific functional characteristics to the packaging material. It should be noted, however, that when we talk about packaging sustainability, the recurring terms like biodegradability, compostability, recyclability, reusability, monomaterials, they always refer to the characteristics of the materials being used as a substrate for printing, or in the composition of the structure of the final package. This material is often chosen by the client, the brand, on the basis of economic and marketing criteria, sometimes, I would say, unfortunately, without worrying too much about the effects on the graphic process. This sometimes requires to adapt or compromise the final quality of the printed product to the characteristics of the substrate. But does the sustainability of packaging depend only on the characteristics of the substrate that we use? How about the rest of the graphic workflow? Does it have no influence at all on the environmental impact of packaging? I really do not think so. Pre-press, plate making, printing activities can significantly contribute in reducing the environmental impact of the entire production process, and finally of the finished product. So what can we do besides the substrate? I mean, us as professionals involved within the graphic production workflow, from designers through pre-press, plate making, and printing. So let's see some possible areas of intervention related to our flexographic process with a series of operations within everyone's reach. First and foremost, you really need to embrace, and implement first methodology and ensure that your full process is calibrated to provide a printing condition that is in control. Relying on a repeatable, predictable, and optimized process will reduce your setup times, minimize the amount of material being wasted, the material waste generated during the printing process, and above all, you will no longer run after your results. These are already indeed some good steps to start towards sustainability. Among the optimization activities, you will find interesting to consider to review and reduce possibly the ink volumes delivered by your analog rolls to improve print quality definition and reduce the impact of energy that is necessary to dry or cure your inks. This would necessarily lead to a new set of characterization data on color profiles that describe how your printing system or your printing condition reproduces the colors. With this information, you can enable any color management strategy, including decisions like whether to add or not any spot colors to help or sustain an existing separation. Having a profile that describes your printing condition would allow you to easily edit useful details like the color of the substrate in the characterization data. In fact, the characterization data inside the profile will show very precious information such as the achievable color gamut, the expected TVIs, and what is the best matching standard condition. A profile is actually showing how you reproduce colors, how you print, the quality that you will provide. Let me ask a question. So, Joe, can we start a poll here? So the question is, do you have one or more color profiles to describe your printing conditions? Okay, and then we can see the results. Joe, I just closed the window, otherwise it clogs my screen. So I will rely on you for the results.
Yes,
let me
that's
add a
fine.
few things, because nowadays brands are more and more often requesting printers to provide a color profile. And that's not only for output preview purposes or like proofing or whatever, but also because they want to know if and how the designated print production will match the desired quality, because all these numbers are inside the color profile. What colors will you use, what TVI, and what is the resulting gamut? Okay, so
Here come the results, Stefano.
okay, yes, I have one or more profiles. That's good, fantastic, fantastic. So that's what I expected. So that the use of profiles is actually a good habit in the industry. Of course, a profile will allow you to know if any color is in or out of gamut. And this is based on figures, on numbers, not just gut feelings to say that it needs an extra color in the separation or to sustain a spot color with a spot color in the separation. You know, this is quite similar to what happens when planning to implement expanded gamut printing without having proper knowledge of what is the actual current CMYK gamut. Let me stress how important this phase is, because it might happen that you surprisingly discover that your current CMYK gamut is already wide enough to cover your needs, and you do not need any extra colors. These examples are coming from two different flexo printers. On the left, the additional OGV, orange, green, violet colors gave an expected extra push to help the CMYK gamut. On the right, the OGV inks are, I may say, useless. The CMYK gamut is already wide enough and can already reproduce these colors. So your journey in process calibration really starts from CMYK. But whether you opt for CMYK plain only or expanded gamut with CMYK OGV, the key aspect is really printing with a fixed color palette that will allow you to save prepress time with fixed separation conditions, printing gagging jobs, shorten your setup and ready times, reduce your color changes and wash-ups, avoid swapping annulus rolls from the press, reduce the leftover inks and storage, use less energy, run faster, reduce solvent retention, and much more. Interesting, during the recent forum, there was a mention that one of the primary reasons why annulus rolls are damaged is because they are moved out of the press. So if you leave your rolls on the press, you have less risk to damage them. One important advantage of a fixed color palette is the possibility to rely on a known output condition and exploit the benefits of color conversion. But how do we do color conversion? Many users are doing something like this. They receive one image that is normally already separated in CMYK with a standard profile, but they remove that profile and they assign the color profile of the flexo printing condition, so they can see how the result would be printed. And this sometimes shows an undesired quality. So they start manipulating, tweaking, tricking, pulling curves up and down, cleaning here, there, until a decent result is achieved. Some operators are very good at this, fast, accurate, reliable. Some are less. But you would agree that this method is definitely subjective, and it raises legitimate doubts about consistency and predictability in pre-press. We know that this method is often chosen because we don't rely on straight color conversion, or because we don't know how to do that in a correct way, straight color conversion between profiles. So, Joe, let's ask a new question here, another poll. How do you manage your separations? Okay, so that's another question for you. And let me say that here I have one of the answers I don't need. This answer could refer to G7 users, because a G7 user may not need to, of course, repurpose or reconvert one image, because they would just print the image on their G7 calibrated printing system. So,
still kind of rolling in, Stefano.
Rolling.
We'll give it a couple more seconds here.
Yeah. In the presentation, I'm referring particularly to foie gras. Bear with me, because in Europe it is still the prevalent standard condition that is used. So and actually it is also foie gras 39, by the way. That is pretty old, but it's changing. It's changing.
Okay, Stefano, there's the results.
Okay, manual editing, that much. Yeah, that much. Color server, that's it. Okay, wow. Interesting, very interesting. So speaking about conversion, one of the main reasons we are typically scared of color profiles is because when we try to do a direct conversion, any color of our original image is first translated to a profile connecting space, a device-independent color mode such as LAB. The destination profile will then determine what percentage of each color channel will be necessary to obtain the original color. Of course, if we have a 50% black, it will be broken into 4 channels, CMYK, that would provide the same color, but adding the instability of 4 inks printing together. Or a blue could be re-separated with a color mix that we don't really like. I personally wouldn't like to have yellow in a blue, right? Moving from the original separation to the destination must be done by connecting the 2 profiles in one device link profile. That will do the work for us without wasting time with subjective manual color conversion and retouching. When building the device link profile, we have the possibility to set our own rules for color management and let the color engine to do the hard work in the time of a click. So we can move from the original separation, again, here it's foie gras 39, and you see the standard CMYK separation of foie gras 39 colors, to an optimized separation that has, in this example, no cyan on pasta and tomatoes, no magenta on green leaves. And this takes really time, a matter of seconds, to do this. This reseparation requires device link profile. It's not possible to do it with direct ICC conversion. So if I have, with the normal direct ICC conversion, if I have a 100% black text, right, text solid, or a background 25% black, or a green made only with cyan and yellow, a normal direct ICC conversion would reproduce the same colors, exactly the same colors, but the resulting CMYK mix would be critical to ensure stability in printing. You see your black, 100% black is broken into 4 channels. The color will be that black, but made with those 4 colors together. When we build the device link, we set what we call the exceptions in color regeneration, transformation. And so a black text will remain 100% solid. The 25% background here would be possibly reduced to compensate for dot gain. So it comes 23. The green will remain only with cyan and yellow, no other colors added. And so would do for all the other colors. Now, this actually happens in real life with the expectations of our customers. And here is a real example where the customer expected to see a nice reddish fawn fur of the dog and a relaxing fresh and green in the background and a stone with a natural look. But the original photo was supplied with for the production that was already separated in CMYK, FOGA 39, with easily predictable problems. That cyan in the fur was not really promising for a nice fawn color. The magenta in the green would have surely led to a grayish result, okay? And the stone color is mostly given by balancing cyan, magenta, and yellow. There's very little black in there. It's a typical skeleton black from FOGA 39. So any little movement or adjustments on the press would be extremely critical and prone to produce huge shifts and definitely errors in the printed results and make our customer unhappy. Now, if I have any color that stays in the quadrant of warm colors, where LAB would have both A and B positive values, well, that color should be reproduced with magenta, yellow, and maybe black only. We don't need any cyan in there. It would just desaturate the color. Same thing in greens. Color would only require cyan and yellow, no magenta. Yeah, maybe a little black. What about yellow in the blues and purples? It's useless. These are what we call opponent colors. If I have a brown like this, and its composition shows 72 magenta, 77 yellow, 46 black, and 35 cyan, what will happen in printing due to press stability, impression changes in viscosity? I'm sure we know how many things can happen in printing. So the changes in cyan will reverberate on our brown. That will result dirty, grayish, unsaturated, and moving. So cyan in brown is just a wrong separation, but it comes from the original file, from the designers, from the original separation. And yes, I know the comments of designers, but what can I do? I don't know where it will be printed. I must use a standard profile for separations. And the standard profiles gives me those values. Why do you blame me for wrong separations? All right. Actually, this could be done right at the design stage. But if it wasn't done then, prepress should consider to optimize the separation even before converting to the flexo destination profile. And this can be done by creating a device link with the same standardized profile in origin and destination, and setting the rules and exceptions for color conversion. So there won't be any cyan in the fur, no magenta in green, right? And we would have the color of our stone made predominantly by black, okay? Here, the original separation was FOGA 39, and it actually remained FOGA 39, same colors, same TVI, but with the new color generation strategy, and by the way, a reduction of 16% in the quantity of ink, and that's not little. In fact, the reduction of the quantity of ink is one of the most interesting outcomes, with all the connected advantages in terms of sustainability that we mentioned earlier. Remember, the energy for drying or curing the ink, the time for press setup, speed, clean colors, and so on. If you're interested, here I have a link where you can just check for some sample separations with their originals and the optimized reseparations, just for your curiosity. All of this is done without any retouching, okay? I remember a presentation from Mark Samworth where he was really pushing on the difference between color retouching, color management, two different things. So it's not subjective editing. Once you have created your device link profile, it takes just a click or your movement in the server. So how do we do this? Well, first of all, you need to get hold of the characterization data that was used to build your standard profile. All this data is available from the source websites such as color.org, Dracul, Fogra, ECI.org, Idea Alliance. And then you can build your own optimized, standardized profile with your choice of color generation strategy. Don't worry, because the printing condition and the output intent remain unchanged. Same colorimetric values of your inks, same dot gain curves. We are only changing the color generation that will determine the mix of the channels in the final color in the the separation from the profile. So your characterization data contain all the information of process aim values of the output conditions. So inside there, you will have your colorimetric numbers, your TVI curves, your gamut. We are not going to touch them. Okay, so we're not going to touch these numbers. We are going to change how the color generation settings are working. In this section of the color profile, this is the section that defines how the CMYK channels are composed and separated when using that profile. Okay, the terms like GCR, UCR, start of the black, and surprisingly enough, the standard profiles that we use in our industry do not have the same settings for color generation strategy. All parameters, such as the use of UCR or GCR or other, the starting point of black, total area coverage, but okay, total area coverage is understandable, are different. And very funny for our friends in Europe, the FOGA 39 profile that you get default from your Adobe programs when you select Prepress Europe 3, that profile is different from the official profile distributed by FOGRA. They have a different GCR. You see GCR 0 or 100. Well, that's a very big difference. The 7 CRPCs of ISO 15339 have increasing total area coverage from 1 to 7. That's okay, we know, okay, because different gamut, increasing gamut. But they have different GCR amount and black start. Wow. So if the standard profiles are all different from each other, then it means that I can make my own customized standard profile, right? So I have the total liberty to do that. So I can decide what settings are ideal for my flexo production and build my own optimized reference standard profile. So once we decide what standard to refer to, we get all the relative characterization data. We define our settings and apply our own color strategy, and we save our optimized color profile. You can use any profiling software, the software that you prefer to do this, provided it has enough advanced and detailed editing capabilities. Once your original separation has been adjusted to the new optimized standard profile, then you can treat your process with your normal method and workflow. G7 would probably not require any further action, right? But or you might want to or need to convert to a different output intent. Here I'm showing a separation from FOGA 39 to a gamut or a separation profile from a corrugated printer. As you see, the exceptions in opponent colors are maintained. There is no magenta in greens, no cyan in browns. But I started with the original separation, okay? I didn't do that just directly on the final flexo profile. A further useful application of optimized standard profiles is the possibility to convert spot colors in CMYK in a better way, just using a normal graphic software without the need of any extra tools. Here I have 3 examples. Can I say X tones? No, we don't want to call them as before, chip tones, whatever. X tones coated that needed to be converted in CMYK. Right. So when I do this with Illustrator, with standard color settings, Prepress Europe 3 in where I live, standard color profile, FOGA 39 in this case, my green is broken in CMYK and I get a fantastic 25% magenta in there. Using the optimized profile, here's what happens. I would say imperceptible color difference and 12% less ink, right? Isn't that good? I think it's good. A purple having B star negative. So why should I need 23% yellow here? Same color can be obtained with 35% less ink. And that's not bad. So let's see the brown that we have seen before. I want no cyan in chocolate, skin tones, bakery, cooked meat, oranges, reds, any warm color. And I think that a delta is 0.5 with just 2 color primaries and a black and 24 ink reduction should be good to go, right? Other examples, here's a list of similar spot colors that I came across recently and needed to be converted in plain CMYK, and they were actually used in production. And of course, you could find more challenging spots that would definitely benefit more of expanded gamut. Here I'm just talking about CMYK, but an average of delta E of 0.5 and a reduction of total area coverage 27% average, I think it's a very good result, right? Sometimes the savings are even more. With 2 color primaries and black, you should also consider a resulting rosette with 3 color angles, not 4 together. So less moire problems, less grainy aspects of your products, of your printed product colors. Your work, if you work with digitally modulated screens, okay, you have no problems of moire, great. You will still enjoy the color remaining on its hue without any opponents pulling towards a direction that would result in a dirty, unsaturated color. So Joe, here you can start another poll when I'm running the next slide. Okay, I'll be showing. Yeah, there you go. I'll be showing some so if we make our flexo plates also to print the same color in highlights with 2 or maximum 3 dots instead of 4. It means that the fewer dots will have a more stable support both on analogs and on substrate, and the color is the same. You see, it's 0.1 delta E. And we avoid to print with those tiny dots that are known to be unstable in printing. Sometimes they create issues related to plate calibration and the use of bump curves when they are necessary, right? So what are the results? What do people prefer from let's say the 4 colors all together, nicely dancing together, or selectively use no opponent colors? So is there any result from the polling?
Yep, here it comes.
Someone will like A. Oh, 0.
Nobody liked it.
Hey.
That's great.
Yeah, it's interesting because some weeks ago I was reading a comment on LinkedIn. Someone exactly speaking about chocolate. Yeah, you know, chocolate requires a little cyan to have that. Yeah. Okay. Funny. We have to think about print production. Okay. When you think about color, print production and variability in print production comes first. So process calibration is key. A stable and predictable printing condition with proper hue values of your primaries and possibly not too high density with controlled TVI and compensation curves, crisp and clean minimum dots, and good ink lay down in solids with low ink volumes will allow you to exploit the best out of your color gamut and contribute to the sustainability of the whole process. Repress and design can further help by building optimized color profiles to provide sustainable separations. You will have colors only where they are needed. Avoid reverberating opponents. Stable and saturated colors. Less trapping. Reduce risks of moire. And you will achieve less variability in production, reduction of your waste, less energy for ink drying and curing, faster printing speed, lower costs, higher overall quality, happy customers, right? So I think that this approach could be useful for the majority of our flexo friends. And I hope I've left you some insights that may be useful for your flexographic process. So let me say again, thank you for inviting me for this session. And I hope you enjoyed this session. And of course, I'm available for any questions that you may have. Grazie.
Yeah, we haven't received any at this point, Stefano, but
wow.
I do want to point out many times people will contact me at the FTA asking for copies of a presentation. Folks, as you can see, Stefano is broadcasting from his computer. I don't have that presentation, but you could reach him at flexo.expert or flexo.training, and I'm sure he will accommodate your request.
Sure. Yeah, I can share the slides, no problem. I have them all.
Great. And I would say if anybody has any questions, now would be the time. We're not seeing any in there, but Stefano, I want to thank you. I guess no questions means you did a terrific job as always. So thank you so much. We really do appreciate it. And I think that's it, Stefano. Ciao.
Thank you very much. Ciao, everybody.
Thank you, everyone. See you on
Bye-bye.
the 25th. Bye-bye.